Hey folks, so just a little while ago we heard from Mike about the radio shop, so there's an update there. If you haven't seen it, you probably want to go see that. Literally just before I sat down to do this, he uploaded that. So anyways, I've got here is, back to old school, I guess you could say. Three segment, three digit 7 segment display rather, and just to replace this with something like this, of course much smaller, and more usable than this. This is just all our breadboard whacked together, but anyway, so this all works. That's the sequence that would go out to the PLL there on the LEDs. And that's basically it. So the only thing I actually have to do that's left is the code for the scanning and the all the I/O stuff that I just breadboard test it right quick to make sure that it's reasonably good. You can do the math, but sometimes the math doesn't equal or equate to reality. Usually it does, but sometimes you have to figure all that stuff out. Actually test it. So, and I like to actually test things. So, that's why I've got tons of breadboards. It's actually one of my newer breadboards that I'm not particularly. I get a lot of Chinese breadboards, and they generally work okay. But this one, they're split here in the middle, and I'm not really. I thought that I would like that, but I really don't, because I got to put jumpers across them and things like that. Unlike some of the other breadboards, like this one, where it's one contiguous long bit with the one bus across the top, which I kind of like. I got quite a few of these, but this one's a Chinese breadboard, and piece of metal with some breadboards probably stuck to the there are no screws in the back, so they're stuck to the this one's a much better board. You see, it's all screwed, so not two-sided tape, just stuck down. But anyway, so microcontroller is an AT Mega 32. The I/O and the display is the I/O is a TCA 9555, and the display is a AS 1108. Neither of which I had any code written for until now, because I'd never used them before. For displays, I used to use a lot of the Max display drivers, but those things are sort of expensive, and they're getting a lot of them I think are not recommended for new designs anymore. When basically Q4, whatever we got, we're going to sell, but once they're gone, they're gone. And those things are like $10, where I think these were like $2. So there's a cost thing there as well. These are cheap. I don't know I'm not familiar with the company that makes them. What I can tell you is DigiKey likes to put the country of origin on the package, and it says that these come from Austria. So they're not Chinese semiconductors. Although the TCA 9555s came from Malaysia. It's a TI part. They don't have vendor as AMS. So for the display driver, it's a European company. Datasheets are very good. I was able to get it going. In fact, I think the datasheet for this display driver is actually one of the best ones I've seen in a long time. They pretty much laid it out. I mean, there was no ambiguity to anything on it. It was very simple to follow. Clear and concise. So that was a big help. Other than that, once I got the other I/O bits worked out, pretty much just throw it in an EDA and get some boards made and give them a go. There really isn't a whole lot to go wrong with this. Some of the initial incarnations like this, nothing went wrong with this either. I mean, they just worked right out of the chute. So the old school ones, and that one actually, this one drove a an OLED display. This one's driving a 7-segment, so I'm going to need 2 boards. One for the display, one for the rest of the logic. And I'm wondering if I can cheat with the chip and somehow get it on the same board as the display, and just simply send SPI over the wire to limit the wiring harness between the display driver and the micro. Because all I'll need is power, and I'll need 5 wires, or 6 to be safe. Pretty much, there's really not a whole lot else to it, because all of the I/O is going to be between these 2 guys. So if I can get the display and the chip on the same board, I will. Something is telling me no, I probably can't, because here's the display. Yes, I got a whole bunch of them. And the pins, they look a little too close for me to stuff the package in between the pins. I don't think that room's real. I don't think that's gonna fly. In fact, let's just see. That ain't gonna fly. Nice try, but it ain't gonna work. So I'll figure something out. Another thing that you can do, that I've done that's sort of tricksy, is you got a board, and this has got your display on it, and then you just have a board that you put some posts, you route out some openings for it, and then you stick it in the back, it's sort of off on an angle like that, and that might work so that you can get the tracks across. You can do that with right angle pin headers, for rigidity, and just, I've done that before. You can route out some holes and have some posts on your other board that fit together, and then but the problem with soldering those pads like that, you got those pads, and then you just sort of put them together and then put solder in the gap there like that, and have it flow over. That works, but in a mobile application, I think that would slowly deteriorate. So I don't know. That might be an option. Just try to keep it compact. I have to measure this and see how much EMI this generates. I suspect that this generates a significant amount, for the simple reason that this is multiplexed. I mean, make no mistake about it. This is multiplexed. So you can't see it, and I think it's going too fast for even the camera to show up as flickering. I don't see it in the display on the camera. It's not flickering, because I think it's running at several 100 kilohertz. So I think it's just the refresh rate on it's really high, but how much interference is this generating? I'm going to have to evaluate that. And the problem with that is, if it is, we can't exactly have, for all intents and purposes, a ribbon cable like this with display data going across it at several hundred kilohertz going around in a radio. We're going to get some kind of an issue. So I don't think that that's really a good idea. So the idea behind it is to keep the data sheet especially said, and you should always read those things clearly, completely, and make sure you understand it all, to keep the display as close to the driver as physically and as electrically possible. And I suspect that is probably because this is going to be very noisy, all of this. So got to give that a go. Got to see what the deal is with that. Try it out. See what happens. So that's basically it. Now, as far as the display goes, like that is, get some light away from it, and try to work on the camera a little bit. I guess that really sort of works. That's obviously channel 9, and going on up. And of course that's all fine. When you get above 40, we just drop the C, because the C, I sort of denoted those are CB channels. The A channels, or the RC channels, like 3A, you see there's 3 and there's a decimal point, and then there's no decimal point there at the end to denote the A, or 3A. So that's probably back to front. I probably need to make that go for one, you know, to -1, -2, -3, -4, -5, negative, so on and so forth. You know, and that's pretty much all you have for, and that's for an 8719. I don't have any lookup tables for any other PLL at the moment in this, so I'll probably be adding those as well. So anyways, that's basically it. Gonna give this a go, gonna see if I can't maybe finish this out this week, and you know, send some Gerbers to China and get some boards and actually try them on a radio and see how that works. The one that's going to take the most engineering is going to be this whole working here. You know, that's going to take a bunch of effort. You know, because ideally, if you want this to work in a base station radio, I think that ultimately the better thing to do would be to sort of make a display mount that'll work for mobile radios and have a plug so that you could switch it out for like base station radios. And for the reason being, let's say you wanted to do this on a Cobra 2000. Well, this display is a little bit small for the Cobra 2000. You could do it, but the Cobra 2000 has a lot more room in there. You can get bigger digits. So, I don't know. That's probably a little bit in the future, but for now, for the mobile radios, getting a board that you can put the encoder on and have that mounted, and then have one that mounts the display is probably the best thing. Have a small jumper that goes from the display to the ribbon cable, and then that ribbon cable would carry the encoder data, the phase data from the encoder and the button, and the SPI data from the display driver up to the board, which hopefully will have the display and the driver on it. I'm gonna have to see. I don't have a whole lot to work with there. It's pretty much just gonna have to be a try it and see, and that means actually getting a length of ribbon cable out and seeing how much noise that generates, because the only way I'm going to know is to try it. I guess I could get in here with a sniffer and you know, the spectrum analyzer and see what it's doing, and that's probably a better bet, just to get an idea, you know, how much RF radiation is being emitted from this, if there's anything that's going to cause me any problems. You know, several hundred kilohertz, you know, across all these wires. So that's basically it, guys. You know, any thoughts, suggestions? Let me hear them. So until next time.